Okay, in this video we are going to prove the alternate interior angles theorem. In the previous video we talked about the corresponding angles theorem and how some books, depending on where you're at, will actually call that a postulate and say it's a common notion, it doesn't need to be proven, and they'll you can show some reasoning to say, yeah, this is pretty obvious. Some other books will prove it, but they'll use transformations to prove it. Specifically a translation. So if you translate a line that preserves the angle measurements, you get those congruent angles. So there's more than one way to get at that first one, the corresponding angles theorem. But once we have that one, the other three, the alternate interior angles theorem, the alternate exterior angles theorem, and the consecutive interior angles theorem, they all kind of fall from the first one, from the corresponding angles theorem. So one of the things I wanted to talk about was one of the ways that you can prove a theorem is to make a diagram. So when we've done proofs in the past, I've given you guys a diagram to help you. And you guys can do that on your own. So if you're trying to prove this theorem, two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. That's a pretty generic statement. There's no pictures or labels or anything, but you can take that statement and you can make an example of it. Now this is still a pretty generic example because we're not talking about specific angle measurements. We're not saying, oh, well this one's 100 degrees and this one is this many degrees, right? We're just labeling them and we're showing that they have to be congruent regardless of what angle measurement they are. So this will help us with this proof quite a bit to go from here, which is just words, to an actual picture. And so if two parallel lines are cut by a transversal, so we say, okay, L and M have to be parallel, and then there's this other line cutting them, so that's this part. And then we want to prove that angle 1 is congruent to angle 3, right? That's one of the pairs of alternate interior angles. So they're on the opposite sides of the transversal, and they're on the opposite lines. Those are your alternate interior angles. So if we can show that 1 is congruent to 3, that proves at least one pair of alternate interior angles are congruent. So this is the setup that we're going to use. And we're going to start, like usual, with our given. So we have that L is parallel to M. Okay? So what we're going to do is we're going to use what we know. Now, we know 2 and 3 are congruent as vertical angles. And we can also use the corresponding angles theorem, because we already talked about that in the previous video. We didn't really prove it. There's kind of a proof that you can do with translations, but we haven't got to translations yet. We talked about that idea in the last video. We also talked about how some people call it a postulate. So whether you want to call it a theorem or a postulate, we're going to say that we know the the corresponding angles are congruent. Okay, so L is parallel to M. That's the first statement. But what does that get us? Why do we care? What happens if we know these are parallel and this is transversal? What do we know? Well, we don't know this yet. That's where we're trying to get. But we do know the corresponding angles have to be congruent. So angle 1 is congruent to angle 2. And how do we know that? Corresponding angles theorem. Okay? What else do we know? Well, we know angle 2 is congruent to angle 3. How do we know that? Well, they're vertical angles, right? We proved that vertical angles theorem before. So, vertical angles. We call it the vertical angles congruence theorem. So I'll use the congruent symbol. Just kind of abbreviate there. Okay. Now, what we have is 1 is congruent to 2, and 2 is congruent to 3. So what can we say now? We can say that angle 1 must be congruent to angle 3. And do you remember how we can do that? This is kind of like the law of syllogism, right? First statement is congruent to the second, we have a if this, then this, and then we have an if, then, and then we go from the first one to the third one. So this is the transitive property. Okay, it's the transitive property of congruence, which we had, right? So we can prove it this way. Now, one thing to be careful of, if you're going to use the transitive property, order matters, right? So you can't go from one, like, let's finish this up really quick. Okay, so here's your proof. This is it. We're done. We proved what we wanted to prove. Let's say we wrote this in a different order, though. Let's say I wrote it like this. Let's say I said, okay, 2 is congruent to 1, and then 2 is congruent to 3. I can't use transitive property here. I don't know if that makes sense, but the order is important. 2 is congruent to 1, the next one should be 1 congruent to something else. So when we're using the transitive property, the right-hand side of the first statement should be the left-hand side of the second statement. It has to go in like a chain. 1, 2, 2, 3, therefore 1, 3. That order is important. So if you happen to write something like this, right, and you're like, oh shoot, I'm stuck, how do I fix this? There's 2 ways to go about it, okay? The first way to go about it is to use the symmetric property of equality. So you could, or symmetric property of congruence. If you write this first and you're like, ah shoot, I wish I had it the other way, then you can just switch it and say, well, then angle 1 is congruent to angle 2 by the symmetric property of congruence. So the symmetric property of congruence allows you to switch them if you ever get it backwards. And then you could use transitive property because we have 1, 2, and then 2, 3. So we can do it now. It's going in the right direction. That's one way to do it. The other thing that we did, we actually proved what we ended up naming the congruent angles theorem, and we showed that if 2 angles are congruent to the same angle, then they're congruent to each other. So if you have, we proved that in, I think it was segment proofs, or sorry, angle proofs 2, I think was the assignment we did that in. But what you could say is you could say angle 1 is congruent to angle 3, but we wouldn't want to use transitive property there. We want to use something else because the order isn't right. So we would use the congruent angles theorem. Okay, so that's something that we proved. It was a side thing that we proved together, that if 2 angles are congruent to the same angle, they must also be congruent to each other. But that's not the transitive property. So you can use, either or, but you have to make sure that if you're going to use transitive property that you set it up right. So for transitive property, one more time, you need angle 1 congruent to angle 2, which is fine. Angle 2 congruent to angle 3. And then when you have 1 to 2 and then 2 to 3, you can go from 1 to 3 by transitive property of congruence in this case. So anyway, there's more than one way to get there, but this I think is the simplest way. If you order your angles in the right way, you can just do it really quickly. We're going to do something very similar on the next proof for the alternate exterior angles. It's almost the same proof, so come back for that one.